I have a pulse that is a 1 millisecond. Pulse is something that is still high, then go low, stay low, and then go high, and that's a pulse. And someone made this video in the internet. So in his video, he's using a switch. I'm not going to use a switch. I'm using a pulse generator continuously. So this circuit work in the sense that this, when the switch is open, this is high, and then when you press the button, that voltage go to zero. You release, stay zero. You release it and go high, and that creates a pulse. The pulse then it gets stretched by this IC that's called 555. Is classic. Everywhere you will find this. Thank you. So here is the 555. I just drew the schematic so I could make a PCB later on. Two resistors define the length of the pulse output. It's just a multiplication. Multiply this number by that number by a constant, and you get whatever pulse you got here, you get it multiplied by this, and you get one pulse. Again, as I said before, I got a pulse of 1 millisecond coming here, or less, or more. At this time, I don't know. So I have a frequency divider here because this pulse is coming with 8 volts. So I needed to cut by 2. I said 10K, 10K, so that would be, if the 8 volts would be 4 volts over here. So I triggered this transistor. That transistor will kind of reverse. It's whatever 1 become a 0, 0 become a 1. So here is a pulse. I bypass this because I didn't like it. So the pulse come here and get a pulse output. The pulse output, again, I put it into another transistor similar to this one. So I get just a ground, what they call sinking output. So from the schematic, I make a PCB, and as you can see here is the position for the IC, and the position for the transistors, and the position for the capacitors that we're using, and the resistors. And this is just a PCB. Thank you. From the schematic, I made a drawing for PCB. From the PCB, I use a router to create a PCB, and now I soldered all the parts. Like you see here, the IC, the capacitors, and the resistors, and the different thing that requires. Thank you. Okay, this is not the final because we're still in the testing stage. Here we have a way to simulate pulse, say pulse. And here we have a way to visualize the pulse. And the pulse is coming in inside the input of the unit, and then I look up the output. As you see, it's coming with a 1 millivolts and 8 volts input. But I reduce that, and then I'm getting out here an amplification of that. This is a 1, 2, 3, 4 times 20, like 80 milliseconds space. Let's see if you can do this. Here, 80 milliseconds. If I switch to 2 milliseconds, then as you see, it continues being more or less the same. If I switch to 3 milliseconds, we're still very much the same. I put an LED here so you can see that when I reduce the frequency, you could reduce the frequency of, it's hard to see, but it could reduce the frequency. But anyway, the visualization should be here. Eventually the final product becoming like this. This is the final. Now we have USB, provide the power of 5 volts. So I don't have to have an external power supply, and input comes from the unit, and then the output actually it comes through the USB, and any trigger signal is coming in the back. So I get in this case, I get 20 inputs, and then I mix them in conjunction with the trigger pulse. Thank you.